In these videos, actually, I will discuss some laws or basic Fourier transformation. So, in this lecture series, actually, I discussed that we need to transform any signal or functions from one time domain to frequency domain. So for this reason, to convert from time domain to frequency domain, we basically perform the Fourier transform. So what is the process, or how can we transform? Just perform a integration from minus infinite to infinite, as I have discussed in back in 2 slides or in this lecture series in previous. You can check there. So basically for the Fourier transform, we need to we need to evaluate the integration from minus infinite into infinite in accordance with the e to the power minus omega t multiplied by the signal we need to transform. But there will have many cases where we actually know the transformation after solving several times. So if we perform, if you actually have the knowledge, or if you have the ultimate Fourier transform of any signal, then we can reduce our calculation in short, like the laws. Like if we have the known laws, like known format, like a plus b whole square is equal to a square plus 2ab plus b square. This is the laws. So how actually we get the laws after multiplication a plus b into a plus b, then we get a square plus 2ab plus b square. So basically this law helps us to short our calculation. So in Fourier transform, although we can calculate the Fourier transform of any signal from integrating minus infinite to infinite in accordance with the e to the power minus j omega t, however, if we have the known transformation, then we can short our calculation. So basically in this lecture I will discuss the some transformation that we need to practice, or we need to know each and every time for calculating the in some major issues or in some practical cases, like in electrical system, RLC circuit or RL circuit. So if we need to transform the one, or this is the signal that, or this is the function we need to transform, then we simply we can practice the Fourier transform of 1 would be twice pi del omega. So if we for a signal function of t, it would be 2 divided by j omega, right? J omega. And for the unit step, it would be pi del omega plus 1 by j omega. For x of minus t, it would be x of minus omega. So here I want to mention that the basic thing should be, the basic thing is that if we have the known Fourier transform, that the Fourier transform of xt is x omega, then if we transform x of minus t, it would be x of minus omega. So if you have to determine the Fourier transform of e to the power at u minus t, then simply we can transform this function as like 1 divided by a minus j omega. For e to the power minus a t ut, it would be 1 divided by a plus j omega. E to the power j omega not t, as we have discussed in the properties, what would be the Fourier transform of that. And simply if we have the Fourier transform of xt is x omega, then for this case, if we have to determine the Fourier transform of this term, simply the x omega should be replaced by the x omega minus omega naught, and the omega can be found from that part. So if we have to determine the Fourier transform of that scenario, like t to the power at ut, then we simply can write a plus j omega square, as we have discussed here in previous lecture. So another important transformation is e to the power minus a mod of t, and in this case it would be twice a divided by a square omega square. And I tried my best to place sequentially so that you can memorize, or you can practice in this way. You will never fall in pitfall or like some in mistake. So after having the several try, I think it would be better and it would be easier for you. So x of t minus t naught, as we have discussed in the properties, if you have to determine the Fourier transform of x of t minus t naught, already you have to and you must have to have the Fourier transform of xt as x omega. Then if you need to Fourier transform, if you need to determine the Fourier transform of x of t minus t naught, then you simply multiply x omega with e to the power minus j omega naught t. So if you need to transform the tx of t, then just multiply or not multiply, actually the you need to differentiate in terms of omega with for x omega. From this and obviously after differentiating you need to multiply with j. So the thing is, if you need to transform txt, or xt would be any function or signal that you need to transform, so then just differentiate that x omega, and x omega is the Fourier transform of xt. So here actually I mistakenly incorporate this Fourier transform. Actually I have discussed already here. So another two important properties, or I should say the basic Fourier transform. This is actually the properties. This is the modulation properties. So in this case, in many cases we will face that we need to transform the Fourier any signal which is multiplied with x omega naught t. That means x1t would be any signal or any functions which is just multiplied with x omega naught t, and if we have to transform these signal or function, then we can just put them in separate, and after placing them just sum up those. So what would be the value of x1 omega? X1 omega basically the Fourier transform of x1t, and we need to transform x1 omega with x1 omega plus omega naught, and omega naught would be grabbed or received from the cos omega naught t, and this is the angular function of that functions. So here x1 omega minus omega naught, and in case of x1 t sine omega naught t, here x1 naught t x1 t multiplied with the cos omega naught t, here x1 t sine omega naught t. For the modulation purpose, or in any modulation, we actually have seen that this scenario, actually for modulation purpose we actually multiply any signal with the cosine and sine term. So these two are the modulation properties of Fourier transform, and we should practice as like this. So in some cases we need to transform the triangular function and rectangular function, and basically we have discussed what is the triangular function, or what would be the graphical representation of triangular and rectangular function, and in this case the Fourier transform of those would be like that. So this in both cases there will have the sinc function, and basically we know the sinc function what is the content of the sinc function. We basically know that, and in this lecture series, basically in some videos we may have the inherent or what actually contains in sinc function we will discuss. And in my previous many lectures I discussed about the sinc function. So in this video I try to summarize or incorporate the basic Fourier transform. And if we face, or if you have any scenario like that in any of them, then just we will transform like that. So in many textbooks or literature you can find these properties, or in website or online, or if you just Google the basic Fourier transform table, you will get many document or pictures or images you can download, or you can